We've had a chance to see some limits that become infinite, but we actually want to get more specific about how to deal with infinite limits today. So to begin with, if you have your graphing calculator, why don't you pull that out and we'll take a look at this picture. Okay, I'll use a window that's similar to the one that's shown there. So it goes from about, looks like -5 to 5 and -10 to 10. Now just a reminder, your TI-83, unless you turn the setting off, it's going to draw the asymptote right there. So just ignore that. The asymptote is just there as kind of trying to illustrate to you. But what we want to be able to predict here is that it becomes negative infinity as I approach from the left and positive infinity as I approach from the right. So we might as well sketch that picture just to have it easy to refer to. So roughly it was like this. Okay, so I'm also going to use the table. So remember, if you haven't done so, you need to make sure that your table setting is on ask. Otherwise, you won't be able to put in the numbers you're looking for. And I'm looking near x equals 2 because that's where the asymptote is. So just to show you, you could do this with the graphical and the numerical approaches to limits that we've tried. So 1.9, 1.99, 1.999. So as I approach 2 from the left side, which is what I'm doing right now, they're becoming very large negatives. And then if I flip over to the right-hand side, as I approach from the right-hand side, they're becoming very large positives. So from this picture or from this table, using the numbers or numerical method for limits, we could figure out that from the left side, this is approaching negative infinity, and from the right side, it's approaching positive infinity. So this was asked earlier, and yes, there is a theorem for it and a proof that it is true. So what you'll need to know here is that if you're looking for a vertical asymptote, as long as these conditions are met, you will have a vertical asymptote. And that is one where the limit of the top is not 0 and the limit of the bottom is 0. Then you will have an asymptote. So basically you can't have a 0 over 0 because remember I said that's an interesting limit. Those are ones that we work harder on and we don't just give up. But if you had something like maybe it was 5 and this one was 0, so 5 divided by 0, this theorem would apply and you would know that there's a vertical asymptote there. So any constant divided by 0, you will have a vertical asymptote. However, it's not true when it's a 0 over 0. As we've already seen, sometimes that means we have to do a little more work to figure out the limit. So I'm going to go through the number line strategy with you here just so you can see how this would work if you wanted to place these pieces together. So can someone tell me, I guess, I'm assuming it's just been cut off. Let me change the resolution here and see what. Okay, so is the left side a negative here? Yep. Okay, and this is a positive? Okay. So what we want to be able to do then is predict whether we're going to be at positive or negative infinity. So what you do is you take up all the factors and you make a number line with them. And this can help you figure out which side we're going to. So let me just walk you through this example in order to show you how it works. So for the first number line, it's going to be equal to 0 when x equals 1. And the other number line is going to be equal to 0 at negative 2. So those are the spots that I'm interested in. This first piece will be negative anywhere that I'm less than 1, and positive for anywhere greater. And same idea over here. If I'm less than negative 2, this will be negative, but positive here. And the reason the number line is handy is now when I want to approach from the left-hand side, I can see what's happening. So we're focused on 1. So if I approach 1 from the left-hand side, this is what I'm doing, is I'm moving this way. So as I get close to 1, we're talking about this area, you know, sort of in here, the left side of 1. What do you think is going to happen to the graph there? Sorry? Yeah, you're right, negative infinity. How did you know that? Well, it's infinite because of the theorem we had before. It's going to be a 1 divided by 0 situation. The reason it's going to be negative infinity is this is a negative times a positive. This number line is trying to show you is that these two pieces, these are the only two pieces that can change whether the graph is positive or negative. And the left piece is a negative, and the right side is a positive. So a negative times a positive will give me a negative, which means I'll have negative infinity when I approach from the left side. Okay, how about if I approach from the right-hand side? So if I approach 1 from the right-hand side, if I wasn't clear. Positive infinity. So this is the way I'm moving, and I'm talking about sort of this area right here, where this is a positive and this is a positive. So this is a 1 divided by 0 situation, which means this theorem applies, and I know I'm going to have a vertical asymptote. Where it's gone is positive infinity because it's a positive times a positive. So that's the kind of predictions that you need to be able to make, is whether it's positive or negative infinity. And a number line is a pretty convenient way to do it. So I'm going to assume that this is the positive, and is that right? So just one more word of caution. Remember this theorem about asymptotes, it does not apply to a 0 over 0 graph. It won't work. Just remember that. If you're going to apply it, you cannot do it when you're 0 divided by 0. That should tell you that there's more work you need to do. Some of those algebraic limits that we worked on a couple of days ago would apply. But in this situation here, for example, if we take a look at starting this one out, I could rewrite this as x plus 1, x minus 1. And where am I going to have vertical asymptotes? I know, it's not even 9 o'clock yet after a long weekend. Thank you. At plus and minus 1. Because what I'm going to have is, if I'm at positive 1, it's going to be 1 divided by 2 times 0. So this is 1 over 0. My vertical asymptote theorem applies. Okay. If it's at negative 1, it's going to be negative 1 over 0 times negative 2. So again, that'll be a negative 1 over 0. Any constant divided by 0 means there's going to be a vertical asymptote. Okay. So you should quickly verify it before you go and jump to number lines and other things, but that's where we're headed here. How many number lines do you think I'm going to need to answer whether it's positive or negative infinity? 2? 1? 8? Well, I'll tell you, it's more than 2, but it's not 8. How many factors would there be in here? Take a look at how many pieces make up this limit. 3 pieces make up the limit, so 3 pieces will decide whether it's positive or negative. So all 3 pieces should go on my number line. So I'm going to have 3 number lines here. The 2 which I believe most of you saw right away were x plus 1 and x minus 1. What am I missing? X, right. X will also have a say in whether or not it's positive, negative, or 0. So you give this a try on your own. See if you can fill in the number lines. Okay, so if you're just still filling them in, double check it against what I've got up here, but your number line should look about like this. There are 3 spots which matter to you, -1, 0, and 1, because at each one of those spots, that's where each one of the pieces becomes a 0. The reason I'm interested at where it becomes a 0 is where it becomes a 0 will tell me the border with positives and negatives, and that's what I need to know here. So now that I have all the 4 regions, I can tell you what's happening. 3 negatives here means I'll be a negative. 2 negatives and a positive means the result will be a positive. 2 positives and a negative means I'll be a negative. And then 3 positives means I'll be a positive. So now we should be able to answer the question, as x approaches 1 from the right-hand side, what will the infinite limit be? Positive infinity, right? Because I'm approaching this way, and it's positive. All right, what if I approach 1 from the left-hand side? Good, negative infinity. And let's see here. What if I approach -1 from the right? Yeah, it's positive infinity. And what if I approach -1 from the left? Negative infinity. So one thing you're going to notice when we do this, they tend to alternate. I say they tend to alternate. They don't always alternate. Like, look at my result, goes negative, positive, negative, positive. Don't be lazy. Sometimes they do go negative, negative, positive, positive. Or sometimes they're bunched differently than you expect. So all I'm saying is, yes, you'll get away with it like 70% of the time, but don't be lazy. It only takes an extra minute to write out all the signs on the number line. So once you have the number line, just follow through with it, okay? I'd like you to try the next one right from the beginning. So see if you can do this piece here all by yourself. Tell me about those infinite limits. Okay, so how you set your number lines up is not going to be the deciding factor, because we might have them in a different order. We should all have 4 number lines though, and when we're done, we should all get the same result. So my results would look like this: positive, negative, positive, negative, and then a positive. So as I approach -2 from the right-hand side, that's right here, I'm positive, so it would be a positive infinity. If I was to graph it, I should see it going up to positive infinity. From the left-hand side, it's over here, it'll be negative. So I should have a negative infinity. As I approach -4 from, I'm going to assume that this is a positive. Is that okay? Then that'll be from this side, which again is negative infinity. And as I approach from the left-hand side, it's positive infinity. So essentially I could tell you where those asymptotes are headed. Could I just see with a quick show of hands how many people had your number lines set up properly here? And how many people had the right infinities there? Okay. We'll keep practicing, but it's good to know that you're getting the hang of the number lines. Okay, so let's see if we can figure out from using limits. If you were to take these graphs, what would be the asymptotes? Like, where would you find them? And can you tell me what you'd be going positive or negative infinity on either side of it? So maybe we should just talk the first one through. So where will you find an asymptote in the first one? Yeah, at x equals -1. Okay, and as I approach from the left-hand side, what do you think? If you're not sure, we can always go back to this. But it kind of seems silly with just one thing there, but that's no problem. It only took an extra 30 seconds. All right, so now when I approach from the left-hand side, what do I get? Yeah, now you can see it. It'll be negative infinity. Here it would be positive infinity. Okay. So again, your job is to figure out where are the asymptotes located, and what are the left and right side limits as you approach. So you try the next two. Okay, so for this next one, we should have 3 number lines there. Where's the asymptote going to be? 3 different asymptotes? 2 different asymptotes? 1? Well, what does the theorem say? How do you get an asymptote? You divide by 0, right? And there's only one spot here where I divide by 0. Remember, more specifically, you have a constant divided by 0. And that does happen here at x equals 1. Okay, remember, it happens when 0, or it doesn't happen if it's 0 divided by 0. You may need to do some more work. There might be an asymptote there, there might not. But we know for sure that if it's a constant divided by 0, there is going to be an asymptote. And that does happen at x equals 1. There is a vertical asymptote. So I can see the left-hand side. So maybe I'll just put it up here. From the left-hand side, it's going to be a positive. It goes to regular positive infinity. And one from the right-hand side is here. It's going to go to negative infinity. Okay, so the next one's kind of a strange one. How would you know cotangent without your graphing calculator? How would you go through this and show your work? Good. So first thing we want to deal with is cosine over sine. Okay. Now we have our two pieces. So here's my number line. Okay, so where does the cosine, or we're just looking from 0 to pi. So if I was to draw a helpful picture for you, most of you would probably be thinking about this part of the unit circle. 0 to pi, just the top half. So if I drew that for you as a big hint, where would I be looking at cosine to be equal to 0? Pi over 2, yeah. So pi over 2 is one of the points I have here. And what about sine? Where am I looking at sine to be equal to 0? Yeah. So there's a 0 here and pi.
Square brackets mean inclusive.
Yes. Yeah. So that means if I was then to talk about where they're positive and negative, we could use the cast rule here, right? Because we're talking about all being positive there and just sine. So what quadrant am I in right now where the pen is? That's quadrant 1 from 0 to pi over 2, right? 90 degrees. So in quadrant 1, they're both positives. And in quadrant 2, sine is positive and cosine is negative. So here I would have a positive, and here I would have a negative. So now I've got a number line. I could tell you about where the graph is positive and negative, but how do I tell you about where it's got an asymptote? Where would it have an asymptote? At 0 and pi, yeah, where I'm dividing by 0. So in this case, at x equals 0. And remember, this interval I've been given, it's not going to include the left side of 0 because it starts at 0. So all I'm looking at is 0 from the right and pi from the left. So if I approach 0 from the right side, what will I end up with for my, what kind of infinity is this? Yeah, positive infinity. Okay, and then what about pi from the left? Negative infinity, good. So just to be clear about my expectations, if I ask you to do this for me, I will want to see number lines to support your work. Otherwise, you have a 50-50 shot at guessing your answer. I suppose, as long as you know where to look. Okay, this is kind of, I don't know. I don't want to say neat. It's not really that. It's not like you're going to go home on Friday night and do this, but we're gonna talk a little bit about math with infinities today and the next lesson that we do. And it's kind of I don't know. It makes it sort of simple to work with when you're dealing with infinities in this case. So let's take a look here. If I have two functions, one which has an infinite limit and one which has just some well-defined constant, like maybe the limit here is 3 and the other limit is infinity, or it could be negative infinity. If I wanted to use the sum and difference this time for infinite limit laws, this is what I'm talking about, is what's the limit as I go to c, and this time I'm having to add the two functions together. Okay. So this is one of those things, like, I don't know if you guys, you know, it's high school, right? And you're late for class, and you're just so annoyed by those people in front of you holding hands, right? And you're like, God, move, come on. Anyways, if one of them happens to whisper, "Oh, I love you, infinity," and the other one says, "I love you, infinity plus one," you can say, "Oh my God, just move on. They're both the same thing," because that's what you just learned here. Infinity plus one is the same thing as infinity according to us. So, nothing? Is it still too early for that? Okay. If you have any constant in infinity, it's just going to be absorbed by the infinity. Okay? You can chuck the other limit. You don't need to consider it. If we're going to do a product where this constant is a positive number, that means I'm talking about the limit as x goes to c of f of x times g of x. The only thing it can do is flip whether it's positive or negative infinity. So in this case, because the limit's greater than 0, it's still going to be infinity. However, in the other situation, when the limit is less than 0, it would be equal to negative infinity, because I'm multiplying by a negative number. Now notice that there is no limit equal to 0. We will talk about this later, but use caution as you approach something like this. It is not just going to be 0, who wins in that case? Well, we'll find out how to deal with it later, but we haven't given you one yet to deal with 0 times infinity. Okay, so then in the quotient, we want to be able to talk about what do we do with this situation? And what do you think? Yeah, it's going to be infinite. What do you think about this? Okay, infinitely small is a good way of discussing it. Yeah, what happens as you become so infinitely small? We call that 0, right? Yeah, nothing. So we would have a limit of 0 here. Now, there is one thing we should note. In this one here, L cannot be 0. That constant, again, this would be an interesting thing for us to consider. What happens if you take an infinite amount of things and divide it up amongst 0? We will have to learn more advanced techniques for dealing with such cases, but for now, we'll avoid those until we're prepared to deal with them. Okay, so using infinite limit laws, what I want to know is it positive or negative infinity? Okay, you don't have to, you can number line it if you need to, but really I just want to see, for example, as x goes to 0, what happens to this whole thing together? You're using the sum law in this case. Okay, in this case, the first piece here is 0, and this piece here, that's a 1 divided by 0. You can use a number line if you really want to verify this, but let's use a bit of common sense here just to show you how it's not always necessary. What kind of number is on the bottom of this fraction? Is it a positive or a negative? How do you know it's positive? It's been squared. So because it's been squared, I know it's going to be a little bit bigger than 0. It's going to be a positive number. So 1 divided by a positive, that's going to be positive infinity. 0 plus positive infinity, that's going to be positive infinity. Okay, again, that limit is easy. It just is 0. This case, 1 over x squared, that again is going to be a positive number, so it will make positive infinity. So altogether, we end up with infinity. Okay. So what does it look like if you go that way? Well, here's just roughly, if this is the asymptote on that graph, it means both sides do this. Instead of getting them going away from each other, both sides do. So remember how I said it doesn't always alternate, like positive, negative? There's your first graph where it went positive, positive. So it is possible. Don't just assume it's going to do that. Okay, so now we're talking about the product rule. Okay, so how would you deal with the limit as x goes to 0 for 1 over x times cosine of x? So should I assume this is still the left side? Okay, so what kind of number is going to be if I go 1 over x and I have from 0 from the left? What's going to come out of this piece here? It's going to be negative, yeah, and it's going to be a negative, right, negative infinity. Okay, cosine of x, what's the limit as I approach 0 for cosine of x? Yeah, it's 1. So the only thing I could do here is change whether it's positive or negative infinity, which it does not change the sign, so it would just be negative infinity for the answer. Okay, this time, however, 1 over x, what would it become as I approach from the right-hand side? It's positive infinity this time. So the limit would be infinity, positive infinity. Okay, so the final one here is using the quotient rule for the infinite limits. And let's see here. On the top, if I was to square this and add 1, it's going to be a 1 over, 2. You think I would know how to add 1 plus 1 by now, right? And cotangent of pi, what's cotangent of pi going to be if I approach from the left side of 1? If you're not sure, right, revert to the definition that you know here, cosine over sine. So this is going to become a, what's cosine of pi? Right? And what's the sine of pi? Okay. So there's clearly some kind of asymptote here. However, I don't have enough information to know whether it's positive or negative infinity. So we could do number lines. You may also remember that we just did it up here. As I approach from the left, it's negative infinity. So what will this become then if I go 2 divided by negative infinity? I have $2 amongst which I must share with an infinite number of people. They will all get nothing. Yes, you get nothing if there's that many people. Right? So try doing, just maybe as a good refresher, how would you find, what's the cotangent, what's the limit as x goes to 1 from the right? If you can't reproduce it because you don't remember, you should be able to come up with it by using a number line for cosine and sine. And all you're looking at then is the neighborhood around where it would be cotangent of pi. So we're approaching from the right side this time. Will it be positive or negative infinity when you get there? Okay, so if I'm less than pi, that means I'm in this part of the quadrants. So if I was less than pi, this would be a negative, while this would be positive. And if I'm greater than, I'm somewhere over here, right? Again, that'll make it only tangent is positive, so both of these would be negatives. So on the left side of pi, the graph is going to be negative, while the right side, the graph will be positive. So if you want to know what's this asymptote going to be, it has to be positive, and I know there's an asymptote, so it has to be positive infinity. So in this case, I'll have 2 over positive infinity. And because I'm still splitting it up in an infinite number of pieces, it's still going to be a 0. Now we're going to talk about sketching curves later, but again, just to show you what's the difference, how do you get there with negative infinity and positive infinity? Well, this is what it would look like in the graph. If it was 2 divided by negative infinity, that means you'd be approaching the top of the graph, like it would be going like this. So it would be making itself, as you go off to infinity, it would be, with my really awesome artistic skills, the graph would be just touching there, hugging that x-axis as you went off to infinity, and it's doing it from the bottom because it's negative, whereas this one would do the same thing but from the top. It would start to come down, and as you got more and more infinite, right, it would be hugging the bottom of the graph. So let me just move those. Questions about finding infinite, negative, positive infinities? All right then, so you guys are off to it.